All right, let's get right into it. If you're anywhere in the enterprise IT world, you already know the drill, right? You rarely just have one job. On any given Tuesday, you might literally be playing network administrator in the morning and then totally switching gears to be the server architect by the afternoon. It is a constant juggling act of provisioning, deploying, and managing some seriously complex infrastructure. So today, in this explainer, we're going to look at how SuperCloud Composer, or SCC, steps right into that reality to streamline your whole workflow. We're going to walk through the entire lifecycle of provisioning an enterprise network environment, taking it all the way from a conceptual sandbox right through to the final switch configurations. Here is our roadmap for today. We'll be covering Part 1, the SuperCloud Composer ecosystem. Part 2, planning your virtual infrastructure. Part 3, defining the network architecture. Part 4, executing the switch configuration. And finally, Part 5, handing off the baton. All right, Part 1, the SuperCloud Composer ecosystem. Now, Supermicro has been rapidly expanding as a total solution provider, and they've built an ecosystem here that is incredibly flexible. The best part? The sheer breadth of compatibility means SCC isn't locking you into proprietary hardware. Not at all. It uses a RESTful API interface to give you this unified dashboard that integrates seamlessly with third-party platforms. We're talking Juniper, Arista, Mellanox. And as the industry really standardizes on SONiC-based switches, SCC fully supports them across a massive spectrum of speeds. Whether you're working with your basic 1G connections or those blazing fast 400G offerings, you're covered. It literally gives admins the power to configure access ports, do firmware updates, and manage port aggregations, all from a single pane of glass. But real quick, before we get too deep, let's ground ourselves with one core capability, 802.1q trunking. This is the networking standard that allows multiple virtual LANs to traverse just a single physical network link. You know, in a virtualized environment, you're constantly passing tagged packets so your VMs can talk to each other. Well, SEC simplifies deploying the standard, right alongside port aggregation protocols like LACP, which we are actually going to see in action in just a minute. Moving right along to Section 2, planning your virtual infrastructure. So, before you ever open up a dashboard or even touch a switch configuration, you have to do the pre-planning. You've got to decide on your hypervisor and your backend storage. Just look at the flexibility you have here: Proxmox, VMware, KVM, Verge.io, Hyper-V. SCC is built to support the interconnectivity of those guest VMs no matter what you choose. For the specific sandbox environment detailed in our sources, they went with a KVM hypervisor utilizing CentOS. And the reason why is great, simply because of a familiarity with Linux. The system basically adapts to your expertise rather than forcing you to adopt to it. Next up in this pre-planning phase is storage. Now, I know there is always a healthy debate in enterprise IT about the absolute best storage technologies, but our sources highlight using an NFS storage server to host the VM data stores. Why? Well, it's inexpensive and super easy to implement in the lab setting. But more importantly, for what we're talking about today, deploying an NFS server perfectly demonstrates the really robust storage networking capabilities of these Supermicro switches. Which brings us to Section 3, defining the network architecture. Okay, so we've got our hypervisor and our storage picked out. Now we have to define the network architecture, and we do this by separating the infrastructure into distinct pathways. Let's break down this blueprint. Fundamentally, we're looking at two totally different streams of traffic. On one side, you have your compute traffic. This is where your VMs need to talk to each other. To make that happen, they use a top-of-rack upstream switch targeting 10G interfaces, and they use that 802.1q trunk port we defined earlier. Then, on the totally opposite side, we have storage traffic. This involves moving heavy data to the NFS server, so it targets much higher speed connections. Think 100G or even 400G. It uses LACP port bounding across two network interface cards to really maximize that performance. Obviously, in a simple lab simulation, you might just use 1G interfaces to test it out, but the architecture itself scales directly to massive 400G enterprise speeds. And here is the exact VLAN blueprint that makes all that compute architecture possible. To let our KVM hypervisor's VMs communicate properly, we are setting up 3 tagged VLANs, 100, 200, and 300, specifically dedicated to compute traffic. We're also keeping VLAN 1 active to allow for native untagged traffic across the trunk. This is the precise mapping we are going to push to our switch. All right, Section 4, executing the switch configuration. This is where the magic of SCC's network provisioning wizard truly shines. It turns that theoretical blueprint into a live environment, and the process is remarkably simple. Step 1, you just input those VLANs, 100, 200, and 300, into the system. Step 2 is the big one, assigning them to a physical uplink port. In the source example, they assign them to Ethernet 11. Why Ethernet 11? Because that specific port acts as the uplink to the corporate L3 switch. And that connection is absolutely vital because it provides internet access, meaning the VMs can actually pull down important software packages from internet mirrors. Finally, step 3, you tag the packets, hit submit, and SCC pushes the configuration directly to the switch. Dub. Now think about the number 22 for a second. It perfectly highlights the sheer speed and power of the SCC user interface. Imagine you have a block of access ports on your switch, say ports 15 through 37, and you need every single one of them to be trunk ports for your virtualized environment. That's 22 individual ports. In a traditional command line interface, you're looking at a pretty tedious, repetitive process, right? But in SuperCloud Composer, with literally one stroke of the mouse, you highlight all 22 ports and instantly convert them from access ports to trunk ports. The whole thing happens in seconds. But look, enterprise IT is all about scale. While the UI wizard is fantastic and incredibly fast for a single switch, what happens when you're deploying a dozen top-of-rack switches? Well, SCC has a northbound API that unlocks massive automation capabilities. Network admins can execute these exact same bulk provisioning tasks across multiple switches at the exact same time using Python or by running an Ansible playbook. It guarantees your infrastructure scales up without bottlenecking your human resources. Which leads us to our final section, Section 5, handing off the baton. Because the truth is, once that network is provisioned, the network administrator's job is essentially done. I really love this quote from the source material because it uses such a perfect metaphor. Enterprise IT really is a relay race. By using SuperCloud Composer, the network admin finishes their leg of the race in absolute record time. Just a few clicks, and the VLANs are created, the trunking is established, the uplink is active. Boom! They can confidently hand the baton right over to the server architects. The infrastructure is completely prepped for the server team to start instantiating those VMs, checking network reachability, and deploying the actual applications that drive the business. So the ultimate takeaway I want to leave you with is this. Efficiency isn't just about saving time on a clock. It's about reallocating human capital. If SXC's unified dashboard can take complex, multi-switch network provisioning from a grueling, days-long task down to a process that takes just a few clicks, what in the world will your IT teams do with all that reclaimed time? What innovative applications are your server architects finally going to have the bandwidth to build next? It's something to think about. Thanks so much for joining me for this explainer, and keep innovating.